Welcome everyone. Today is the session 19 of JEE Physics. The chapter is current electricity, and I have taken this question which was asked in the JEE mains examination in 2013. So this is a question. Now in this question there are 6 equal resistances which are connected as shown in the figure. This is the figure which was given along with this question. So in this question, the value of each resistance is capital R, and they are connected as shown in this figure. So the question is, net resistance is maximum between P and Q. This is option number A. The option number B is P and R. The option C is Q between the point Q and R, and the option D is between any 2 points. So in this case, as we can see that these three resistance, these three are connected in parallel, and these two resistance are also connected in parallel. So I will be just drawing another figure in which I will be taking the equivalent resistance of these three resistances, and I will be taking the equivalent resistance of these two resistance which is connected between these 2 points, that is Q and R. So the equivalent figure in which I will be taking the equivalent resistance of the resistors which are connected between this point Q and R and the point P and R. So since these three resistors are connected in parallel, and if their equivalent resistance is say R1, then 1 by R1 will be equal to 1 by R plus 1 by R plus 1 by R. So it implies that R1 will be equal to R by 3. Okay, so this is the value of this R1, which is the equivalent resistance of these three resistors, is equal to R by 3. Similarly, since these two resistances are connected in parallel between these 2 points, that is Q and R, so their equivalent resistance, say it is R2, will be equal to 1 by R2 is equal to 1 by R plus 1 by R. So it implies that R2 will be equal to R by 2. So this is equal to R by 2. Okay, so I have drawn this figure. This is the point P, this is the point Q, and this is the point R. So I have drawn this figure in which I have taken the equivalent resistance of these three resistors between the point P and R, which is equal to R by 3, and I have taken the equivalent resistance of these two resistors which are connected between the point Q and R, which is equal to R by 2. Now we have to find the net resistance between the points P and Q. So now first thing is that I will be now calculating the net resistance between P and Q, between the points P and Q. ठीक है, so ये क्या होगा? Now if I am considering the point P and Q, then R1 and R2 are in series. So in this case R1 and R2 are in series. ठीक है, this is the first point. Second thing, the equivalent resistance of R1 and R2. The equivalent resistance of R1 and R2 is in parallel, to this resistor R, is in parallel to this resistor R, which is connected between the point P and Q. So now, it implies that now the equivalent resistance of R1 and R2, okay? The equivalent resistance of R1 and R2, because they are connected in series, so this will be equal to equivalent resistance of R1 and R2, because they are connected in series, will be equal to, means that simply it will be, we will be adding up. So R1 plus R, the equivalent resistance will be equal to R by 3 plus R by 2. So this is equal to 6 5R divided by 6. So this is the equivalent resistance of R1 and R2, and this is in parallel to this resistor R, which is connected between the point P and Q. So the net resistance between P and Q, net resistance between P and Q, say I'm just taking it as, say, RPQ. Okay, so it will be given by that is 1 upon R PQ will be equal to 1 by R plus 1 divided by 5R by 6. Okay, because the equivalent of R1 and R2 is in parallel to the resistor R, which is connected between the point P and Q. So this will be equal to 1 by R, that is 1 divided by R plus 1 divided by the equivalent of R1 and R2, which is equal to 1 divided by 5R by 6. It means that it will be equal to 6 by 5R. So it implies that 1 by RPQ will be equal to, if I take the LCM, so I will be getting as 5R. And here it will be 5 plus 6, which will equal to 11 by 5R. So it implies that RPQ is equal to 5R upon 11. So the net resistance between the point P and Q is equal to 5R divided by 11. So we have found this, the value of the net resistance between the point P and Q. Now we will be finding the net resistance between the point P and R. So I will now writing this value, because I have got this value of the net resistance between the point P and Q as 5R by 11. So I will be writing this here. R PQ is equal to 5R divided by 11. Okay. Now we have to find the net resistance between the points this P and R. So now in this case, what will happen? So the next point is net resistance between P and R. So in this case, this resistor R, that is between the point P and Q, and the equivalent and this resistance, that is R2, and this R2 is basically was the equivalent resistance of these two resistors which were which are so placed between these two points, that is Q and R. So R2 was the equivalent resistance of these two resistors. So in the case of when we have to find the net resistance between the point P and R. So in that case, this resistor R and this R2, they are in series. So first point is R and this R2, which is equal to R by 2, they are in series. This is the first point. Second point, the equivalent of R and R2 is in parallel to R1. So using these two concepts, we will be able to find the net resistance between the point P and R. So it implies that now the equivalent resistance of R and R2, ठीक है, वो कितना होगा? This is equivalent resistance of R and R2, because they are in series, so this will be equal to R plus R by 2. So this is equal to 3R by 2. Now this will be in parallel to this R1. So the net resistance between the point P and R, say it is RPR. I am denoting the net resistance between the point P and R as RPR. So this will be equal to 1 by R1. So 1 by R1 will be equal to 3 by R plus 1 divided by the equivalent resistance of R and R2. So this is equal to 1 divided by 3R divided by 2. So that will be equal to 2 divided by 3R. So if I take the LCM here, it will be 3R, and then I will be getting 9 plus 2, which is, so this is equal to 11 by 3R. Okay, so it implies that the resistance, or you can say the net resistance between the point P and R is equal to 3R by 11. Okay, the net resistance between the point P and R, the net resistance between the point P and R is equal to 3R upon 11. Okay, so this is how we have to calculate the net resistance between the two points in this question. Now the third case is, now we have to find the net resistance between the point Q and R. Okay, so net resistance between Q and R, between Q and R. So इस केस में क्या होगा? This resistor R and this is the R1 is the equivalent resistance of these three resistors, this and this. So which is equal to R by 3. So this R and R1, they are in series, that is R and R1 are in series. This is the first point. And the second point is that the equivalent of R and R1, equivalent of R and R1 are in parallel to R2. Okay? So this is, so now the equivalent of R and R1 is what? Equivalent of R and R1. This will be equal to, equivalent of R and R1 will be equal to R plus R by 3, because these two are in पैरेलल. सो ये हो जाएगा मेरा 3R plus R, that is equal to 4R by 3. And the equivalent of R and R1 is in parallel to R2. So it implies that since the equivalent of R and R1 is in parallel to to R2, then we can write that 1 divided by RQR, where RQR is the net resistance between these two points, that is between the point Q and R. This is equal to 1 by R by 2, ठीक है, because the equivalent of this R and R1 is in parallel to R2. R2 is equal to R by 2. So 1 by, and this R2 is in since it is in parallel to the equivalent of R and R1, therefore 1 by RQR, where RQR is the net resistance between the point Q and R. So 1 divided by RQR is equal to 1 divided by R2, which is equal to 2 by R, plus 1 divided by 4R by 3, which is equal to 3 ऊपर हो जाएगा, 4 नीचे आ जाएगा. Now I will be taking the LCM, which is equal to 4R, and here I will be getting 8 plus 3. So this is equal to 11 divided by 4R. ठीक है. So it implies that RQR, that is the net resistance between the point Q and R, will be equal to 4R divided by 11. So I will just write it here, that is RQR is equal to 4R divided by 11. So these are the three values of the net resistance which I have found between the point PQ, the point that is P and R, and the point Q and R. ठीक है. So from these three values we can see that the net resistance is maximum in the case of this P and Q, that is the net resistance is maximum between the point P and Q. ठीक है, because यहाँ पर जो है RPQ is equal to 5 by 11, and ठीक है, ये RPQ is equal to 5R by 11 है, and RPR is 3R by 11 है. So R and RQR is equal to 4R by 11. Now RPR क्या हुआ, PQ is greater than RQR, and this is greater than RPR, that is RPR. ठीक है, इसकी वैल्यू है 5R divided by 11. The net resistance between the point Q and R is 4R by 11, and the net resistance between the point P and R is 3 by 11. So the net resistance is maximum between the points P and Q. So our correct option is A. So now if you look at this question, you will find that this question is very easy, because it is very easy to find the equivalent the resistance of these three resistors which are connected between these point P and Q, because they are in parallel, so you can easily find it out. So I have found this equivalent resistance, which was equal to R by 3. Similarly, I found the equivalent resistance of the resistance which is fitted between the point Q and R. So this was equal to R by 2. Okay, and so after finding the equivalent resistance of these resistors, we were able to find the net resistance between the point P and Q, the point P and R, and the point Q and R, and we got these three values. So finally we found that the net resistance is maximum in the between the point P and Q. Okay, so this is the relation which we got. So the question was asked in the JEE mains examination in 2013. It was a, if you see at this question, this is a very easy question. Okay, the only why I was just wanted to discuss this question in this session, because you will see that in JEE mains examinations you will find you will come across very easy questions. The only thing is that you have to have a good computation skills, because in this question you have to be very quick in solving these you have to be very quick in solving this problem, because you have to find the equivalent resistance between the 2 points. So उस केस में क्या है, अगर आपकी कंपटीशन स्किल अच्छी होगी तो आप इस क्वेश्चन को जल्दी से जल्दी कर पाएंगे. So that is the only thing just which I wanted to mention here. The question was very easy, and so in the next session, that is in the session number 20, I will be coming up with another question from the same chapter, that is current electricity. So thank you very much for joining this session, and I hope you have understood the solution of this question. So till then, have a nice day. Bye.